Hello, my name is Vanessa. In this session, we will explore the science behind the rocket and how the UK is investing in global space market like building spaceports. Take a minute and discuss in your group what is a spaceport and why do you think we need spaceports? If you guess that spaceports are the port to the space, then you're absolutely right. They are like Aberdeen Airport or Aberdeen Harbour, but instead of having planes or ships, they have rockets to be launched.
Most of the early spaceports were designed to test rockets for military or scientific purposes. Modern spaceports now have different roles. In addition to scientific research, they are also being used for commercial purposes such as space tourism.
The space sector is rapidly growing, and the UK it's been renowned for its space industry. The UK satellite industry is currently employing over 42,000 people, a number that is increasing with projects like building spaceports. Take a moment and discuss in your groups. Have you ever watched a rocket being launched? What's the difference between a vertical launch and an horizontal launch? What about fuel consumption or the weight of the payload? Well done! I'm sure most of you have guessed it right. If you have seen a rocket being launched, you probably have seen a vertical launch where the rocket is going upward, while a horizontal launch involves a specialized spacecraft that takes off horizontally.
Vertical launches are still the preferred method for heavier payloads, but they need more fuel. However, horizontal launches can be carried out more frequently by adapting existing facilities such as airport. Therefore, here in Scotland, plans are now underway to develop vertical launch sites at Sutherland, Western Isles, and Shetland, and horizontal launch sites at Glasgow Prestwick Airport and Campbelltown Airport.
One of the main differences between the launches is thrust. Take a moment and discuss in your group what do you understand by the term thrust.
Thrust is defined as a force of a jet or rocket engine used for propulsion. It is a sudden or violent push in a specified direction. Compared to vertical launches, horizontal ones require less thrust to reach high altitudes. So, to generate some thrust, the vertical and horizontal spacecrafts use different types of engines.
Now that we know about rocket and launches, let's make our own and find the science behind it.
For this investigation, we will need a balloon pump, string, straw, tape, scissors, and a clip. Fill up the balloon with air using the pump. Close the opening of the balloon with a clip. Fix a piece of straw with some tape on one side of the balloon. Take a long string and insert the straw in it. Keep the thread straight or tie it up somewhere like a window, a tree, a doorknob. Now, release the balloon.
What do you think will happen? Would the balloon move along the string or will it stay in one place? What do you think is pushing the balloon and why? Take a moment and discuss in your group.
When we let go the balloon moves. The air inside the balloon comes out from one direction and pushes the balloon to the opposite direction. However, Would it be matter if there's less or more air inside the balloon? Would the shape of the balloon have any effect? What about the length of the straw? Does the angle of the strings has any effect on how far or fast the rocket travels? Try these different conditions in your groups.
In every rocket, including our air rocket, the basic principle is the Newton's third law of motion. For every action, there's an equal and opposite reaction.
For example, while rowing, we push the oar backwards in order to push the boat forward. Therefore, to make a rocket move to one direction, we need to apply an equal force from the opposite direction.
In our investigation, our rocket is a balloon which is very light, so we can move it only using air. But what about real rockets? Do you think only using air is enough? Take a moment and discuss in your groups what a rocket can need to be launched from the ground.
Being able to launch a rocket from the ground, we need to consider the weight of the rocket, including the materials used to build it, and the amount of load to be lifted as well. Therefore, rockets need fuel, something similar to petrol, diesel, or hydrogen for cars and buses. To provide the enormous amount of energy to push rockets into the air, we use the chemical reaction. When rocket engines are ignited, the exhaust gases are released, producing a downward force. The opposite force creates an upward thrust. When the rocket produces more thrust than its weight, it will lift up into the air. The explosive combination of fuel and oxygen has so far powered all our space exploration.
So, thinking back to horizontal and vertical launches, now we know that horizontal launches require less thrust, require less fuel, if we compare with the vertical ones. As you know, there are plans to build and operate Spaceport in Scotland. One of the launch sites will be in Shetland, the UK's most northerly island. Through this project, we aim to inspire and engage everyone about UK's growing space sector and share all the exciting news about spaceports. So this brings us to the challenge part for this session. For our investigation, we use a balloon as a rocket and launch it horizontally. What about doing a rocket using something else? That's part of your challenge. Can you use a recycled plastic bottle, a cardboard tube? What about wooden stick and a straw? Which kind of fuel these rockets need to move? And what about the launch? Can it be horizontal or vertical? Try all this challenge and send us these pictures and videos with us. Here at the Aberdeen Science Centre, we have this exhibit that is the air rocket, which uses air to launch the rocket.
We also have this exhibit to know and understand what NASA do, all the information about various NASA missions and space exploration programs. So if you haven't visited us already, we look forward to seeing you soon. Until then, goodbye.